Welcome back, everybody, to another episode of the Health Mastery Show. Today I have on with me a guest who I've been looking to get on for a very long time. I know I say that quite frequently, but I was really looking forward to this. This person, I read their content all of the time, their scientific papers, in my research, in trying to answer questions, and that is Professor Luc Van Loon. So Luc is a professor of physiology and exercise at the Department of Human Biology at Maastricht University Medical Centre. He has an international research standing in the area of skeletal muscle metabolism, and his current research lab, which is called M3, focuses on skeletal muscle adaptive response to exercise and the impact of nutritional and pharmacological interventions to modulate muscle metabolism in health and disease. So his main areas of interest research in his laboratory are muscle metabolism, sports nutrition, clinical nutrition, adaptation to endurance and resistance exercise, and the use of physical activity and nutritional interventions with aging and chronic health conditions. So that's a lot, but Luc has been around for a while and he's published a ton of papers. So in this episode, we get into talking about the effects of plant proteins and are they effective. We also talk about how he translates nutrition science into science or practical application for aging and elderly populations. And we also touch a little bit on some supplements and carbohydrate supplementation and a few other things as well. But a really interesting conversation, and I hope you enjoy it. But without further ado, let's get into the episode with Professor Luc Van Loon. Luc, thanks so much for coming on the podcast today.
You're welcome. Happy to do it.
Yeah, and I know it's been a while trying to get you on, but I think this is one of the more exciting ones that I've been looking forward to. As we mentioned just before we came on air, I've read tons of your work and from your lab as well, having studied sports nutrition, and I think you're probably one of the most prolific sports nutrition researchers worldwide, I would say. I think most people will know your name. So for those perhaps who don't, it would be great to get a bit of an intro into yourself, your background, how you got to where you are today. If you can keep that into a couple of minutes, because I know it's probably we could probably talk the whole time about your accomplishments.
Yeah, it's not so shocking. I mean, I'm a professor at Maastricht University, just a researcher. We have a research group of around 30 people where we study the interaction between nutrition and physical activity, ranging from sports nutrition in the athletes all the way to nutritional care of the intensive care unit patients. So that's it.
Yeah, well, I think that was a bit humble, but yeah. So what's something that you're kind of really excited to be working on at the moment? Is there anything novel or interesting that kind of keeps you awake at night that you're thinking about?
Oh, there's a lot of things that keep me awake at night, but most of the work we're doing recently is a lot of looking at more sustainable protein sources, because that is a societal interesting topic that we get a lot of questions about. So there's also a lot of interest from industry into that topic. And so we started to look a lot on plant-based proteins. And we've taken a few steps further on, already looking at insect-derived proteins. So that's fun. I mean, it's novel, and we'll see where that brings us in the future.
Yeah, it's a really interesting topic. That I guess there's two sides from that. One is looking at perhaps the utility from, say, a muscle building or muscle maintenance and muscle protein synthesis effect, and then the other side of it is, say, the more lifestyle things like palatability, getting people to actually eat that stuff, and then also the sustainability. Is plant protein and like insect protein, is that more sustainable if that was rolled out across the world? Because I know we often hear people talking about sustainability, but when you actually scale something to a worldwide population, do these things actually become more sustainable and economic, etc.? Is that something you've looked into?
Yeah, I'm afraid you have to ask somebody who works on sustainability, because I only ask questions on the topics of sustainability. And when we're talking about sustainability and we're looking into plant-based proteins, and I'm talking about plant-based protein isolates and concentrates, they are actually being processed to get them out of the rest stream of vegetables or anything like that. But of course, then the whole sustainable issue is questionable, because if you put a lot of effort in getting that protein out of the plants, how sustainable is that protein that you end up with? That also depends, of course, in the total recycling. I mean, if it's a rest stream and you can make something beneficial out of a rest stream, out of basically garbage, then it's a benefit. But if you're actually throwing away a lot of plant-based food sources in order to extract the protein, then of course we're talking about a different situation. So it's always very difficult to understand what sustainability is. Think about these, for example, the wind energy. In the sustainability energy, do you also take into account the building of the fans, the disposable of the concrete and all of that stuff? So it's topics that I know a little bit about, but I'm certainly everything but an expert in that.
Yeah, so these are questions that I just wonder myself when you think about, it's a little bit off topic, but when people are talking about shop local and, don't buy from large multinational companies that ship across the world, but often the emissions or the carbon footprint from the transport element of these foods are not actually what the main outputs are from. They're from the production, whether it's meat production, it's or the feeding of the cattle or the production of the foods rather than the actual transportation. But so like you said, it's a topic for another day and probably another person on another podcast, but it's interesting.
Yeah, no, I mean it's an interesting topic, and I had somebody just really violently responding in a conference saying that that person is a vegan and therefore more sustainable. And I said I'm not sure whether vegan and sustainability are necessarily the same thing, because I think it's more sustainable that if you have cattle and they die of a normal death. I mean, do you bury them or do you eat them? I mean, eating them would be actually more sustainable. And I would take it one step further. If you're actually eating a dead animal is going to be more sustainable than burying it. So necessarily being a vegan is not necessarily more sustainable. So it's the topic of sustainability is much more difficult.
Yeah. So when it comes to looking at the plant proteins, because obviously that question is something that is at the forefront of everybody's mind now, what is it that you guys look at in your lab in terms of, is it the muscle protein synthetic response and how that can be a replacement for athletes or for humans?
Yeah, so one of the questions is, of course, protein quality. And we do a lot of studies in looking at protein quality. And in the past, we've, of course, used the intrinsically labeled protein method in order to assess differences in digestion and absorption, uptake, release, but also incorporation into muscle and muscle protein synthesis, following, for example, whey protein versus casein. But now we get questions on plant-based proteins, whether they have the same anabolic properties. And so we, but also other groups have started to do that kind of work. There's not a lot of work being done in that area, really, on looking on muscle protein synthesis in vivo in humans. But we know that, for example, wheat protein and soy protein do not seem to have the same anabolic properties as milk or the milk proteins. So it seems that they have a lesser anabolic potential, and that is, of course, explainable due to the fact that, in general, plant-based proteins have less essential amino acids that particularly lower in leucine content, which is an important stimulatory factor in from all the amino acids stimulating muscle protein synthesis. And a lot of the plant-based proteins are deficient in specific amino acids. So if you take one specific amino acid or one specific plant-based protein and you compare it with an animal-based protein, in general, you might find a lower anabolic response. Now, we started testing different proteins, but also different protein blends, so you can lift up, compensate for any specific deficiencies because you combine different plant-based sources. And then the differences, can be present or they cannot be present, but it depends also on the situation. You can compensate for a lesser quality by ingesting more protein. Again, it's not rocket science. If you have some deficiencies or less leucine, but you just ingest more of the same protein, you can compensate for that. We've shown that with wheat protein, you can achieve the same anabolic response than an animal-derived protein, but you simply have to ingest nearly twice as much of it. And that is also a relationship with, a lot of people are asking questions based on the documentary on the Game Changers. And then they're saying like, oh, you can actually gain a lot of muscle, and that's novel when you eat only plant-based proteins. No, of course. If you're a 120 kilogram or 100 kilogram NFL player, and you consume a huge amount of food because you actually have a high energy expenditure and you're training all day, you naturally already consume a huge amount of protein. I mean, even a 60 kilogram Tour de France athlete will actually consume about 25 to 30 megajoules of energy per day. If he or she only consumes about 10 energy percent protein, they will still consume more than 3 grams of protein per kilogram body mass per day. So that's an overwhelming amount, much more than what is needed. So if you have a lesser quality protein in that diet, it's not going to matter. It's going to be fine. And that's exactly what you see in the documentary. It's nothing magic about it.
Would that be protein from, say, like, I would say indirect protein sources, so from the likes of breads and pastas and things like that, and oatmeal? Is that where the protein is kind of adding up?
Yes, that's where the protein comes from. And then, of course, the other side is there a difference between plant-based proteins when they're still in their whole foods matrix, or whether they ingest it as protein isolates, like a pre-protein that you can actually use in your post-workout milkshake? There's a difference, because the digestibility of a lot of plant-based proteins is less when they are actually consumed in a whole foods matrix. So in general, you could actually speculate that if you consume a lot of plant-based protein sources, that you have to eat more in order to get the same bioavailability of the protein in those whole food sources.
Yeah, that's really interesting. So you already mentioned that perhaps the anabolic effect of wheat protein or plant-based proteins is not as effective per dose as that of milk-based or animal-based proteins, because of the leucine content, but you can compensate by essentially eating more. I assume that's when you get to like the 2 or 3 grams of leucine, right? Probably around that amount where you cap it off. And I think looking at some of the research, it was like you need 40 grams of wheat compared to maybe 20 of whey, right? But when you're looking at those studies, is that plant-based protein, is that from a protein powder where it's actually being isolated from the plants? And then if that was eaten, it, like you said, in the food matrix as, I don't know, 8 slices of brown bread or something like that, does that mean that you probably actually need to eat even more protein because of these fiber and the outer shells of the grains, etc.?
I mean, this is a great question, and this is something that science is struggling with, because what we like to do is we would like to answer a specific question, and for that we need to take out all of the factors that we don't know anything about. So when we look at the anabolic response to protein feeding, we love to use a single protein, for example, whey or casein, and then don't add any carbohydrates or other stuff, but simply use that protein and see what is happening. But except for bodybuilders, we don't consume, or a lot of athletes, we don't consume protein powders. We consume foods. And in foods, we actually have a lot of other factors. We have other macronutrients. We generally have a combination of different proteins. Then we have, of all the products that you consume in a single meal, they're being processed. We now know that heating protein, storage of protein also has effects on the bioavailability and therefore also the biofunctionality of the proteins. So if you consume a full meal, all of these things come together. And most of the research is not being done with meals. Why? Because then if we find differences, we don't know where the difference comes from. And it gives us, from a scientific perspective, doesn't give us much answers. But to be honest, I think we slowly have to move forward to whole foods based research, and then all the way to mixed meals in order to see what a meal really does. But it's tricky because we need to figure out which factors are actually affecting the anabolic response to feeding when we change something in the meal. For example, if you skip out the potatoes, or you skip out the meal, or you heat it, or you use a microwave versus a normal prepared meal. If you then compare, you don't know what caused a potential difference that comes out of the study. So that is the difficulty. But the translation from protein powders to whole meals, that's tricky.
And how do you see the future of, say, plant protein in the diet? Because, as you know, unless somebody is a informed athlete or perhaps like a bodybuilder, something that's kind of very conscious of the protein intake, a lot of people, they're not even conscious that, like, I don't know, a glass of milk is a good protein source, or like chicken breast or something is like a protein source. That's quite common, a lot of people. Then if you have these different protein sources that are from plants that need to be combined in order to maximize the anabolism, that even becomes even more complex? Or is it the fact that you shouldn't let great be the hindrance of good? Shouldn't let great stop being good, in the sense that we will eat meals that are not maximizing anabolism, quote unquote, but are still good, if that makes sense. Is that the way you kind of see it?
Yeah, I can bring it back to what I said just before we started this podcast. I mean, I started with my PhD mainly on carbohydrate metabolism and interaction with fat metabolism. And then basically most of the applied research was related to how can you maximize performance and glycogen resynthesis with ingesting enough carbohydrates, and what kind of carbohydrates and the amount and the timing. After that, we realized that also the intramuscular triglycerides are an important substrate source. So we started doing studies in my postdoc on how the intramuscular triglycerides are a substrate source during and following exercise, and how they can be stored optimally, and how this functional storage leads to diabetes and is associated with obesity. And then we actually moved towards protein metabolism. So funny enough, I mean, even in my career, first carbohydrates, then proteins or fats, and now proteins. And suddenly we have three macronutrients, meaning foods. So we need all three components, but we generally study only one in each specific study. But of course, with food, all of these three macronutrients come together, plus a whole range of other nutritional elements.
Yeah, it's really interesting. I remember when I first, because I compete in bodybuilding, and when I first started learning my nutrition, it was from forums, maybe 15 years ago, and it was following bodybuilders, like professional bodybuilders, and they would often not combine certain food groups. They wouldn't combine fat and carbs together because the insulin's release from the carbohydrates should actually then be the storage hormone for the fat. So if you mix them together, then it's crazy how when people get a little bit of knowledge, they then conflate things into these hypotheses where you shouldn't combine certain foods.
We try to simplify things, and then we only work with the knowledge that we have. And of course, if you get stuff like that, it's always difficult for us as well. You learn that insulin is an anabolic hormone, but that doesn't mean you use that more is better. And that's of course in general with athletes and with people not in the topic. They will simply say, okay, this is stimulatory, so we give more, and it's more stimulatory. It doesn't work like that.
Yeah.
It was a topic that we did some studies in the past as well, to see whether weight gainers with protein plus carbohydrate has a greater anabolic response than simply only the protein. Because you've seen this. In the 80s, the weight gainers were being sold more than the protein supplements, and actually the product itself per kilogram is cheaper because carbohydrates are generally cheaper than protein, but they were being sold as a higher price. So in short, it was just a good marketing scam. But if you give the protein and you add small amounts of larger amounts of carbohydrates, it doesn't affect the anabolic response to feeding. Of course, carbohydrates can be relevant if you want to restore your glycogen, but for your protein synthetic response after a workout, the carbohydrates are not needed when you give an ample amount of protein. So the greater insulin is not going to have a greater effect. And there's very nice laboratory-based studies where they show that you only need about 15 microunits per mil of insulin to facilitate a maximal muscle protein synthetic response. So in other words, after many studies by different groups, we basically figured out is that insulin is permissive, but not necessarily stimulatory. So you need a certain amount of insulin to allow a maximum stimulation of muscle protein synthesis, but more is not necessarily better.
I've seen, there's been work, I think it's from your lab and also from Stu Phillips' lab, looking at that, the addition of carbs to, I'm not sure if you guys did amino acids or protein, but it didn't have any impact above the actual protein dose.
Yes, there's studies from McMaster, but also from Galveston, and there's some very nice work from Paul Greenhalgh in England on that's more the mechanistic point of view on insulin clamps and the effect it has on protein synthesis. But they all point the same way.
And what do you mean by the permissive effect of insulin? You mentioned permissive. What exactly do you mean by that?
Well, you need the insulin to allow the anabolic stimulation to take place and to allow the amino acids to be taken up in the muscle. So insulin is necessary, but above a certain level, more is not better.
Yeah, that's really interesting. And then when it comes to Glycogen resynthesis. You talked a little bit about that. How important is glycogen or having carbohydrates post workout in order to maximize glycogen resynthesis in, say, somebody who doesn't compete in multi-day events? So I've read some research that when total carbohydrate intake for the day is matched, that glycogen at a 24-hour period, so your muscle glycogen will be the same levels, even if there was a gap. I think it was of 2 hours post workout. But then one caveat that kind of leaves a burning question for me is that the subjects who actually waited 2 hours, they were having, I think it was the same amount of feedings, but they're having something like 200 grams of carbohydrates every couple of hours, but they were like high GI carbohydrates, so some sort of sugars, which doesn't, as we kind of talked about a bit earlier, doesn't represent real world. People don't eat 200 grams of jelly babies every 3 hours for 24 hours. That's just not real world. So is there actual utility in a real world setting where people are having mixed meals and say they're training once a day? Is there utility in having carbohydrates, fast carbohydrates or sugars, say, post workout in that, say, half an hour period or close to your workout?
Based on the work that has been done, and Louise Burke has done some really nice work on 24-hour glycogen resynthesis. I mean, most of the work shows that if you consume enough food in energy balance with a normal diet, then your glycogen resynthesis is optimized or is restored back to normal within 24 hours. So in general, with a normal workout, your glycogen content should not be limiting your performance during your workout sessions. So for normal workout sessions, you don't have to maximize glycogen resynthesis. So I don't see much need in carbohydrate ingestion immediately after exercise, unless you have to optimize performance, for example, the next day, and you have completely depleted your glycogen. Think of a cyclist in the Tour de France, for example. But otherwise, I mean, if you're going to play soccer on Saturday and you want to have a maximal performance the week later on Saturday, don't think too much about carbohydrates because it's not going to limit, and certainly not for the recreational athletes, because you also have to consider the fact that even though the high performance athletes will actually be trained to use less glycogen, their glycogen use is still high because they have such a high performance capacity. And if you're just a mediocre athlete, I mean, your glycogen use is not going to be that heavy, because if your maximal workload capacity is half of a high performance athlete, also your carbohydrates use is not going to be huge.
Yeah, that's a topic that a lot of people, I guess, they get confused on. What about, say, like professional athletes who do train every day? Would that even make a difference? Because I know you'll see with say soccer athletes, like professionals, they will be like having post-workout shakes and things like these, and rugby players and basketball players. Does it even have any, like, if somebody's trying to get that last 1-2%, does it make any difference if they're not recreational athletes?
No, I think if you're a professional athlete, you want to optimize performance, so you want to maintain or regain the glycogen levels that you have before the next training session, especially if your training sessions last more than 2 hours and are intense. But with a high performance athlete, your overall energy intake is so high that in order to maintain energy balance, you will already consume a huge amount of carbohydrates on a daily basis. So that will cover your glycogen resynthesis. I mean, most of the nutrients that we, fortunately, in most people, most of the nutrients that we need is being consumed by food, not by supplements.
Yeah.
Supplements is basically a lazy way of getting the nutrients you want to maximize performance or reconditioning. So think about a sports drink during cycling is simply easier to ingest when compared to a plate of pasta, because that doesn't work handy when you're sitting on a bike. Secondly, if you're going to the gym and you have a 2-hour train ride to get back home, you can't have your normal meal after your training session. So in that case, a protein shake or a protein bar is going to help. So it's just a practical alternative way to get the nutrients you want. But it doesn't, I mean, it's not at the expense of food. It shouldn't be at the expense of healthy foods.
Yeah. That's a I guess a really important point, and I think a lot of people kind of have to pay their due diligence and spend tons of money on supplements and realize that they don't actually have much of an impact. When it comes to, say, like the importance of whole foods,
I think what you're saying is important, but I think you have to make it more positive. You can have a huge impact with nutrition. But that works mainly through the diet, because the supplements are only a very small part of the total nutrients you consume on a daily basis.
Yeah.
And that's why food can have a much greater impact, because it is the main source of our nutrients.
And what are your thoughts, say, from a psychological perspective? Let's say you talked a little bit about weight gainers at the start or before we start recording. From a perspective of somebody who's trying to eat more, let's say to either increase energy intake for a sporting performance or simply to be in a positive energy balance to gain muscle or weight, it would be easier technically for somebody to, say, consume a whey protein maltodextrin blend, your typical off-the-shelf weight gainer, versus making an extra pasta dish, especially if they're somebody who, say, has a very high metabolism and struggles to eat a lot of food. What are your thoughts on in supplements in those scenarios? And I'm not talking about supplements in like Tribulis or something, these bunk supplements.
No. So I always make the difference between sports nutrition. With sports nutrition, a lot of people already think of supplements, but if I actually talk about sports nutrition, then I talk about a diet that is optimized for performance and reconditioning, and that can include sports nutrition supplements, in order to make it easier to consume the required nutrients in a situation where it's more practical. It's like, think about having a bowl of pasta while you're cycling. That doesn't work, so you have a sports drink. And then there's, of course, the supplements that you buy on the internet that have all these crazy effects, and supposedly, or sometimes they even have substances in there that are actually forbidden. I call those nutraceuticals.
Yeah.
Because it's somewhere between nutrition and pharmaceuticals, like creatine. I mean, if you want to ingest 20 grams of creatine with normal foods, you probably have to slaughter half a cow on a daily basis. So with 20 grams of powder, that's easier, but that's no longer nutrition, because that's not a normal amount that you get in nutrition. So I call those nutraceuticals. But if you're talking about sports nutrition supplements, so in the line of normal foods, then you always have to consider the fact that we only know a very small amount of things about nutrition. I mean, if I talk about flavonoids or carotenoids or whatever, I mean, 20 years ago, we didn't even talk about these nutritional elements. And so all of these other factors are in nutrition, and they are generally in healthy nutrition. In the sports nutrition supplements, we've taken all of that stuff out. So there's a lot of stuff that might be really of benefit that we don't know it exists. We don't even have a name for them. So I would only take the supplements because, I mean, it's the name already says it, to supplement something when you can't get your food in, your nutrients in through normal nutrition. And so just get your head out of your ass and just cook a nice protein-rich snack, and don't resort always to consuming also prepared foods like protein drinks or protein bars. Yeah,
that's a really, really interesting topic that I would love to see more research on in the future, is the effects of these non-essential plant properties and their effect on body composition and health.
But what is interesting, I mean, now you're saying it's interesting to do research on stuff that you don't know it exists.
Yeah. Exactly. I mean, yeah. So there's probably a lot of stuff in plants that we don't even know exist and have synergistic effects.
Remember, look at, for example, the literature, or the literature, not the literature, the internet. It will tell you about the existence of bioactive peptides, and I see it all the time. There's bioactive peptides. I love to believe that there's bioactive peptides, so small peptides that have a biological function. But to what extent are they actually taken up in the gut? Because most of the protein is, of course, converted to free amino acids and then taken up. But there are transporters for small peptides. So are there small peptides that have a biological function? Is that just a marketing stunt, or do they really exist? Are they being made in the body, or are they really taken up from your product? And then, do they have a function? I mean, that is just another factor. I mean, are there bioactive peptides, and is it real? I mean, this is stuff that, but then consider the fact that you have a bioactive peptide of somewhere between 5 and maybe 15 amino acids. There's a lot of different bioactive peptides that you can make. So which one are you going to look for? That is tricky.
Yeah. Like when I was looking at some of the literature on, say, how to maximize natural testosterone, there's some stuff on plant sterols or other, like I said, non-essential stuff, flavonoids, carotenoids, as you mentioned, other these kind of things that give plants their color and their shape and etc. And that isn't clear if they have, say, long-term impacts or even acute impacts. But it's because at the moment, all we kind of seem to think is, or at least what the research that we have at the moment is that when you kind of match your calories and your macronutrient profiles in the short term, at least, it doesn't really seem to make a huge difference, as long as you're not deficient or you have adequate intake of micronutrients, your vitamins and your minerals. But we don't really look at these plant properties. But then, as you mentioned, sometimes people can take advantage of that and say they have this new bioactive peptide, and then they sell this unique thing. What are your thoughts on, say, I don't know if you've ever heard of a guy called David Sinclair. I think he's a researcher from Harvard. He had I think it's called resveratrol, is it? The extract from grapes.
Yeah.
And they looked at, I haven't looked too much into the research, but I do believe that at some point it was cited as this magical anti-aging property or supplement, but then perhaps it actually doesn't have the impacts they necessarily thought it would. Are there kind of, do you think there's, say, these emerging substances from plants that perhaps may have, that are being looked at the moment, that perhaps may have these effects that were almost pharmaceutical like down the line?
Yeah, I mean, these things pop up all the time, and generally they pop up after in vitro analysis and screening for anabolic potential or anything like that. And you have, for example, compounds out of the skin of apples. You have the azelaic acid, for example, the resveratrol that we know from wine and from grapes, and all of these compounds seem to do a lot of stuff. But then, if you want to consume them to a level that they could do something in the human body, then we're talking about huge amounts that you can't really ingest in the form of grapes or in the form of apple skins. So the question is, do they really have an effect if you consume them in such high levels? And are there potentially also adverse effects? To be honest, in most cases, results end up being disappointing in a practical sense. That is not to say that the research is not interesting, because the research learns us a lot how the cells work and how the human system works. But I don't think there are magical bullets. And the best bullet we have is consistent nutrition and training, and keep that up and try to just live a little bit more healthy. And for example, eating more plant-based foods is going to help you. Not necessarily from what is in the plants, but also from the fact that it's just much more difficult to consume the same amount of energy from a diet that has more plants, because it has much more fiber, it has much more water. So it helps people to reduce energy intake. And of course, with most people, I'm generally not talking about the athletes, simply eating less is probably the best health advice that you can give to most of the world's population, or at least the Western population.
Yeah, I think if you want to get lean or get leaner, you almost have to eat fruits and vegetables, not because of their unique properties themselves, but the combination of the water content, the fiber content, the food volume. It just makes it so easy that it's almost impossible to have a high fiber, low calorie dense diet without eating lots of fruits and vegetables.
But then, to be honest, I mean, I know this, you know this, but it's always difficult because, I mean, vegetables you generally have to prepare, you have to keep fresh, and you don't have the time, or you think you don't have the time, and you end up not eating enough veggies. I mean, that is just a fact. And that is difficult for people, but I mean, we know, I mean, in so many cases, we know what we need to do. But yeah, doing it is the most difficult step, of course.
And then we have the challenge of perhaps socially deprived areas where the food is not available and they don't have the cooking skills and all of these things, which is not something that I'm necessarily an expert on, and is something for public policy and again probably for another podcast. But it's not quite as easy as, because sometimes, and this is definitely the way that I taught a few years ago, is that everybody is just personal responsibility. Everybody just needs to eat less food, and it's not perhaps quite as simple as that. Maybe for people who have a bit more maybe in a bit more affluent areas and things like that, and can afford to cook and eat. And yeah.
I mean, I remember one of the radio shows, a popular radio show in the Netherlands, and they called me in the morning, and the most important question that they had was, what should I eat to lose weight? And they expected a whole range of stuff, and I said less. That's the only thing I said, less. And then it was all quiet, and then I thought, like, yeah, that actually makes sense, doesn't it?
Yes.
But that's just humans. I mean, it's the same thing. Like I'm 105 kilograms. I love cycling. My bike is probably 8.9 kilograms. I probably paid a few $100 more for a bike that was less than 10 kilograms. Well, I could actually save a lot of money by just losing 10 kilograms.
I've heard that one before. Yeah, it's quite funny. Yeah, the human mind boggles sometimes. But when we talk about aging, healthy aging, because we did say we discussed this a little bit for the next few minutes, was what can people learn, general populations learn from sports nutrition in terms of healthy aging? And then I guess the question will be, what is healthy aging? Is it biomarkers we're looking for? Is it subjective feeling? Is it muscle mass? Is it lifespan? Or
yeah, very good question. I mean, I think we can learn a lot from the sports nutrition in healthcare, but also prevention of illness. Because I mean, that's the main thing I'm doing at the moment, is basically explain how simple the sports nutrition research has been, and why, and asking the question why we're not applying this in healthcare more. We know that when you become, I mean, you are what you eat. I mean, we've used the intrinsically labeled protein procedures, so we infuse cows with labeled amino acids. It's for the cows to actually incorporate those labeled amino acids in the milk. We extract the milk protein from the milk and use that in clinical studies in order to really assess digestion, absorption, how much of the protein becomes available as amino acids, and how does it stimulate muscle protein synthesis. So we can follow the trajectory of protein throughout the entire body, all the way to conversion into your own muscle. So basically showing you are what you eat. Now with exercise, we can actually see that you are, if you are active before you eat, you are more of what you just ate. So you make more efficient use of your protein. And then you can actually see how you can modulate this further by changing protein source, or the amount, or the timing, or the type of exercise, etc. But of course, in athletes, it can always be compensated by the fact that athletes consume a huge amount of food. So quality, as I just said with the plant-based proteins, is not a major issue if you consume a wealth of protein. But if you actually are a compromised patient, or you are a person not moving a lot, your food intake, your energy requirements are much lower. So your food intake is lower, so quality becomes more important. Mm-hmm. Quality becomes more important when your food intake is lower. So when people go to the hospital for a new hip or a new knee, we see that their protein intake is, I mean, organizations in the world suggest that you have to be somewhere between 1.2 to 2 grams per kilogram body mass per day, depending on who you believe. The reality is that they get about 0.8 grams of protein per kilogram body mass per day through their diet that is being provided next to their bed. But they, in reality, they only consume 0.5. And this is in a good hospital here in Maastricht, where, I mean, this is a high-profile hospital. They only consume 0.5 grams of protein per kilogram body mass per day. In a patient that is trying to recover, has to rebuild muscle, has to rebuild collagen, connective tissue, etc. So they are severely underfed. So there's severe protein malnutrition. Now, if we then also pick up the rehabilitation after the surgery, I mean, you can just add up. I mean, these people should actually consume more protein. The protein should be combined with the training, just like an athlete, and it's not happening. And of course, I think being able to walk again and do all your stuff is sometimes more important than having a gold medal in a recreational competition. So why are we not using everything we know in sports nutrition in healthcare? So I think the topic of clinical sports nutrition is very essential. And we have to start using the knowledge we have in order to optimize health and performance. And that is basically what healthy aging is about, to overcome short periods of muscle loss due to sickness or surgery or hospitalization. Because generally we leave the hospital with less muscle, less strength, and then we don't regain. And then all the way up to the next session, you actually, you already lost even more muscle. You don't regain it. And then with the next corona episode, flu, or your next surgery, you lose more. And then within 10 years, you can't live independently anymore, and you have to be institutionalized. And you spend the last 20 or 10 years of your life institutionalized. And that is something that you want to prevent, but you need to start working on that.
Yeah, I remember like when I've been in the hospital before for like overnight, you get feeding of like toast with butter and probably not enough calories, and obviously if you're immobilized, you're not activating any kind of muscle protein synthesis from exercise. So I think in the ideal hospital there would be those electromagnetic stimulation things that would contract and you would get protein every couple of hours. But I guess funding is probably a huge.
Yeah, but that's I agree. I mean, we've used the electrical stimulation to show that there's no diffuse atrophy when you're immobilized, and we even used it in coma patients to show that there's hardly any muscle loss during comatose conditions when you give electrical stimulation twice a day. But it's not what we need. If you're not in a coma and your leg is not completely immobilized, you can get out of bed 3 or 4 or 5 times a day, or preferably do not spend any time in bed throughout the day. And so it's much more simple than that. I mean, any lecture anywhere in the world, I've always asked people, where's the TV in the hospital room? And the answer, I don't know how they do it, every culture, every country, whatever language they speak, it's always the same. The TV is on top of the bed. It makes sense. People are being fed in the bed. We've done studies to show that also chewing, but also sitting upright has an effect on digestion and absorption. So don't feed people in bed if it's not necessary. Get them out of bed, feed them on a table, make them sit upright, chew well. I mean, it sounds really like your mom is talking to you, but those factors are important in stimulating muscle protein synthesis and therefore preventing muscle loss. And so just try to make a hospital a more normal living situation for those patients that are capable of achieving that. And that will actually prevent much of the muscle loss that we're having. And generally, it's I think the amount of exercise that is required to not lose huge amounts is very little.
Yeah, I think kind of a tangential topic, but when a lot of people started working from home because of the pandemic response, people were paying a lot of money for these like extravagant comfy chairs because they were getting like hip pain or lower back pain or neck pain. But the problem is actually not that you want to be really comfortable, because if you want to be really comfortable, you lie in bed on your back with the laptop and you'll be really comfy, but you're going to be very, very sore because you're not using those muscles. The same when people get those braces to help them like stand up straight. It's like, well, actually you're immobilizing that muscle the same way as you're wearing a cast on your arm. So it's not actually helping. It's actually probably making it worse. And as soon as you take that off, you're going to feel terrible.
It can help as a step up, but in the long term, it's not going to help. I mean, it's the same with diets. I mean, why do all these diets work for the first few weeks? Because you disrupt the metabolism from the homeostatic setting that you've actually achieved yourself. And then the body doesn't know how to react, or it takes time to react to it, and then it gets back to normal. So you can use those early interventions in order to change some of your body weight, but it's not. I mean, it's not something that will work always, because our body is much more smart than we think. I mean, we are much more flexible. If we change our diet to much less carbohydrates or much more fat or much less protein, the body will adapt. The body will adapt to diets, because if that wasn't the case, the dinosaurs would be walking around and not humans.
Yeah, that's another really, really interesting topic to me is the metabolic flexibility and doing different intensities of exercise and manipulating diet to kind of manipulate oxidation and the kind of where people get confused in terms of for fat loss and energy production. But I guess we don't have time, and perhaps another time that would be something we could chat about. But where can people find more information about you and your work?
We have a website, the M3 Research Group, is www.m3-research.nl.org. I don't even know.
I'll put it in the show notes.
Yeah, that's information of the people that work in our group and all the theses that they published. You can actually download them, but also there's a link to all the papers that we've published and a short description of the techniques that we use in the facilities that we use. And of course, you can also address me if you want. Yeah, and for the rest, just depending on what you want to know, use PubMed. Don't believe all the crap on YouTube and stuff like that, but try to get. I mean, if you're interested in the science, stick to the scientific publications and try to understand those. If you don't know anything about it, you don't have a background in science, sometimes it doesn't help reading papers because most people can't discriminate a good paper from a bad paper or a different technique from the other one. For that, it needs some expertise. And so don't only read the headlines because sometimes the headlines are not necessarily what the paper finds.
Yeah. That's a great little point to leave us on, and I really appreciate you coming on, Luc.
Happy to do it. Lots of topics to discuss, and happy to come back anytime you want me to.